Okay, the graph theory in this is quite tough. So I've done a bit of graph work over here to save time in the video, but the first one here is the distance between, or the difference between the highest and the lowest watermarks. So a sine graph, a normal sine graph, I did it here, the green one, has a highest value of 1 and a lowest value of -1. So that's just the sine of t. So if you put a number in front of it, like, I don't know, 7, then essentially what you're doing is you're multiplying every value down here by 7. So instead of the highest value of the graph being 1, sorry, I'm going to take these out. So here's the highest value of the graph, which is 1. It's now going to be 7 times 1. So the highest value of the graph is going to be 7. The lowest value of the graph then, you can see it from the graph. So the lowest value of the graph is here, which is -1. So -7. Yeah? So whenever a number is there in front of the sign, tells you the highest. So you can see I've already got it highlighted. In front of the graph is 6.5, which means the max value of the graph is 6.5 and the minimum value of the graph is -6.5. So the difference is just add those two together. So 13 meters. Difference between high and low. Okay, the period of the graph. So I tried to do this to make this as clear as possible. So that same place I've showed you on the formula and tables book a few times, pi/6 is 30 degrees. So essentially what I did was here I went up in multiples of 30. So 30 degrees sine is 0.5, at 60 degrees it's 0.9, at 90 degrees it's 1, and so on and so forth. Okay, and then over here on the right I did 2 times t. Okay, and you can see down here, so the green graph is sine of t. So it goes up to the top, back down, and back to the beginning in 360 degrees. So 360 degrees is the period, or 2 pi. Whereas sine of 2t, where all I did was just doubled t. Like that's what I did, and I got the sine. And you can see came from the graph that we've halved the period. So instead of a full revolution, top, bottom, back to the start, taking 360 degrees, only taking 180 degrees. So what's it, pi or 180 degrees is the period. So if you multiply t by 2, you halve the period. Yeah? So in this case, we haven't multiplied t by 2. We've multiplied t by pi/6. So then we need to take what it should be, which is 2 pi, divide it by pi/6, because that's what happened over here. So when I multiplied it by 2, the period divided by 2. So if I multiply by pi/6, then the period should divide by pi/6. So 2 pi divided by pi/6. What should I just do? Sorry. 2 pi divided by pi/6 is 12. So 12 hours is the period. Calculate the time at which the first high tide occurs and the depth of the water. Okay, so the first high tide I think we can probably plot this. The period is 12 hours, so I am typing into my calculator using the function 7.5 minus 6.5 sine. I have my calculator in radians, so I'm doing pi/6. I don't have a t, but I do have an x. So alpha x equals, and I'm going to start at 0, I'm going to end at 12, and I'm going to go up in steps of 1. Okay, so I'm getting a high tide at... First high tide. I'm getting a high tide at... 9 hours. And the depth of the tide is 14 meters. And that's just from typing into my calculator. So I literally typed this in as a function. And I started at 0. I ended at 12 because that's what the period was. And I went up in steps of 1. And I'm looking for the highest value reached. And it is 14. It goes back down after that. Nine hours and 14 meters. Use the depth function to show... Oh, I've actually just done this, haven't I? Okay, so we're going to type in 7.5 minus 6.5 sine pi over 6. And I'm using x instead of t, just because I don't have a t on my calculator. I'm going to start at 0. According to this... Oh, no. Sorry, start again. Sine of x. Okay. So I'm starting at 0. I'm ending at 24 according to this. And I'm going up in steps of 3. Okay, so at midnight, the tide is 7.5, then 1, then 7.5, then there's your 14. Then 7.5, 1, 7.5, 14, and 7.5. Okay. So at midnight, it is going to be 7.5, which is exactly halfway between 5 and 10. Then it goes down to 1, so that is 5, 4, 3, 2, 1. And then 6 goes back up to 7.5. 9 o'clock goes all the way up to, oh, I've lost the line, 14, which is there. Then 12 o'clock, it is back to 7.5. Then 1. Then 7.5. 21 is back up 14. Did I do that right? Oh, I hope I did. Yeah, I did. And then the last one is 7.5, which is here again. Where's 0? Here. So it goes... There we go.